Toplap Lisbon, nós somos membros criamos este coletivo há pouco tempo e estamos a promover live coding de música e algo raves em Portugal. E hoje vamos falar um bocado da linguagem que a gente usa para tocarmos um com o outro e sozinhos, que chama-se Tidal, e basicamente é uma linguagem feita on top de Haskell, que interage com o Super Collider, que é o motor de áudio que a gente usa para fazer sons, basicamente, para tocarmos e para criar sintetizadores. Ok, então.
Olá, eu sou Candera. Como o Afonso disse, pronto, dentro do live coding que nós chamamos live coding, que é talvez um pouco diferente do live coding normal de demo scene, é nós estamos a correr código no REPL, onde podemos arbitrariamente correr pedaços de código, como se fosse um Jupyter Notebook ou um Hydrogen para quem usa Python. Então, basicamente, nós fazemos código inline e corremos inline e temos por trás uma linha de comandos que está a receber isso e a fazer route, dependendo do software que está a ser utilizado. No nosso caso, nós por acaso utilizamos o mesmo, que se chama Tidal Cycles. Foi desenvolvido para aí há 10 anos atrás e está a correr em cima. E não é um sound engine, ou seja, a única coisa que este engine faz tem uma sintaxe muito simples que nos permite gerar padrões e atribuir-lhes operações a esses padrões, e depois esses padrões são enviados por OSC para um audio engine. Neste caso, o audio engine que nós utilizamos é o Super Collider, que é um outro software que gera som, onde se podem definir quaisquer...
Sorry. If you could speak English, we have
some... Oh, shit. I'm so sorry
we
about
didn't notify
that.
you, so
I'll redo from the start.
Yeah, okay, thank you.
I'm so sorry. That
No,
was
that's fine.
such a lapse. I don't know why we started in Portuguese. Anyways, hi, I'm Candera. We use this coding language called Tidal Cycles. It's built on Haskell. And basically, it's a coding language that allows you to generate patterns via very simple commands. These commands are being converted into OSC messages that are sent to another software called, in this case, Super Collider, that grabs those commands and turns them into audio signals via your computer's sound card, basically. Super Collider has been going on for like 25 years, something like that. Yeah, there's this movement that we are a part of called Algo Rave, which is basically making raves out of algorithmic music. It was started about 20 years ago. We were both very young at the time. And then Tidal, which is the one we use to basically simplify the syntax of Super Collider, which can be quite verbose, has been on for like 10 years, more or less. In our collective, we have other members that use different languages, such as, for example, Foxdot, which is built on Python, or Sonic Pi, which is built on Ruby. They are basically like, you can think of them as like front ends to interact with Super Collider. So basically they allow you to write syntax and commands that are then turned into audio in Super Collider. So the other layer that we're gonna introduce, so we don't go too deep on this, is the input that the software in which we input the commands. In this case, we are going to use something called Flock, which is quite cool. It's an open source project that runs on any browser, including your mobile phone or whatever. And basically, it allows you to create interactive terminals on your browser that send messages via web to whoever is logged into this session. So basically, it creates a session. You can join as many people as you want, and then, for example, I'm the one. My computer is the one that says Candera, and Afonso's, I don't know if you can see. Yeah, write something. Yeah, Afonso is the one that says Endron. That's our artist names. You can also search us if you want. So basically you can do cooperative and collaborative live coding using this platform. When I perform, for example, I use Atom, which is the open source code editor. It's yeah, you also have it, and or you can, if you wanted to, you could do it in the command line. Basically, you can be very flexible with this.
So basically, Tidal is just an OSC dispatcher. So you can actually use it to control anything you can use to control OSC with, and so we basically. Here in this software, we are both interacting with Tidal, which then creates OSC messages, in this case on my laptop, that sends it to Super Collider, and depending on the messages that Super Collider gets, it generates the sounds that either that we have added or that are already there by default. Yeah, so...
We can ask if there's questions so far.
Yeah. So I think that's pretty much the higher level of it. If there is any question, if not, we can start jamming a bit. Okay, cool.
Yeah, just so Afonso is gonna start typing something. Basically, the way this syntax goes is you have these things called orbits, which are basically audio buses. And right now we're going to use buses 1 through 6, I think. That's what we arranged between us. So, for example, D3 means go into orbit 3. Do something simpler.
Okay, yeah.
Just do like a hi-hat or something like that. Yeah. So, for example, on orbit 1, you're going to play S, which goes for sound, and you're going to play NK. Yeah, exactly. Oh, yeah. And now we're playing every loop. Do the set CPS on top so they can see. So here you'd set how many beats per minute. So 170 beats per minute. Afonso likes to go really fast. And now you have a kick going times 4. So you can either do that or you can type it 4 times. Type it 4 times, Afonso. Like, yeah. Yeah, it's a bit muffled, but that's the sound system. It's not us.
Boo!
We're not blaming the organization. Yeah, so there you could do like 4 kicks, for example. Yeah, you can do like you can attribute MIDI. So now we're doing 0, 0, 0, which means don't change anything. So it's gonna sound the same. But now if you change one of them to, for example, 2, then it's gonna go higher. So it's super simple to manipulate, as you can see. So now you're gonna play one note at 0, another 3 pitched up, 5 pitched up, and 12 pitched up.
No, this is the pitch. Oh, instead of up, I can call it note as well. These are similar parameters. So here I can sequence the MIDI notes, and basically how Tidal works is in between these 2 square brackets, it represents 1 cycle, which is equal to 4 beats on, in this case, 170 BPM. So basically, anything that I fit in between these 2 brackets is going to be equally divided in time for 1 cycle. So basically, if I add a 5th one, it's going to sound a bit weird because we're used to having 4s in 1 cycle, but it's going to fit the exact same time slot. Yeah, 1 extra.
Now 6. So now, for example, we can do cool stuff like you can put a pattern inside the pattern. So, for example, put something in there. Yeah. So now, those in between those brackets, they're gonna go in 1 beat. So.
In between the brackets is the same as if it was only 1 event extended by time, basically. So the brackets mean that whatever is inside them will be equal in time to what would be the time of a whole event.
Yeah, maybe to make it easier to understand, we can do like just 4 beats here.
Yeah.
And then on the 3rd beat, yeah. So first beat goes 0, 2nd beat goes 3, 3rd beat goes 12, 12, 12, 12, 4th beat goes 15. So you can see how this can go really mad really fast once you start applying math to these things. Because of course you can multiply, divide, subtract, add anything you want. And also you can add effects and other functions to it. So I think like now you have an idea, a basic idea. We're gonna jam for a bit, and then we'll be back to you. Oh, and on the other side, we're using another language that does graphics. So usually when we perform, we're doing both at the same time, which is very stressful. But I think I'll work a bit on that in the beginning while Afonso does the music, and then I'll join in. Basically, it's called Hydra. It's basically a syntax layer on top of JavaScript. As you can also imagine, they are really bad at naming these things, as most programmers are. So it's impossible to Google anything. So if you have a bug, you sort it out. And these are both developed by a single person. Bless them, they're amazing, they're awesome. We can pay them coffee, I guess. And then it's JavaScript based, but the syntax you will see is very simplified to make it very fast. I'll start with generating some noise algorithms, and I'll put in some other layers on top. Let's see how it goes.
Just
Yeah, that was a little demo. We tried to make it short. I don't know if we went over time. Are we good on time still? We could go for, as you can imagine, like 12 hours of this. So
We could go forever.
now I think we can open up to questions. Yeah, it's running on the computer. You can show the console, maybe the
Basically, this part here is a website called Vlog. So this is just a front end for Tidal, which is this side here, the left side. Yeah, left side exactly, and then right side is Super Collider. So basically, what Flock does, the website part sends messages here. Basically, this is the code that we were evaluating, and then this sends the message to Tidal through this one, which doesn't need a terminal. It's just running inside this one, and Tidal then just dispatches OSC messages to Super Collider, which was the one on the right, and that's what actually generates a sound. And in this case, Kendera, they're just writing on the website, and when it evaluates on my laptop, which is currently running Super Collider, which is the audio server. Yeah, on my machine.
For example, I ran this, and now if we go to the
Super Collider, you can see.
here I ran.
Yeah, there is the code that Kendera ran, and here you can see that every cycle it sends one hi-hat message. This is basically the OSC that Tidal sends. I modded it to print out to the Super Collider console. So yeah, that's basically the messages that Tidal sent. So you can actually use it to control anything that can be controlled by OSC. You just need to mod these messages. Yeah.
Yeah. You can intercept any of those OSC messages, whatever you want. You use a listener, any listener. Yeah, and then if you use that syntax, you're good. Yeah. This is actually built not on vanilla Super Collider. We didn't say that. It's this plugin called SuperDirt for Super Collider that actually does the conversion from this syntax into Super Collider syntax.
But you can also, for example, you can also pick up these messages and have like a pure data patch or something like that, and use it and use Tidal to control that as well. It's also or modulars. Yeah, you can also convert it to MIDI. I also use it with a lot of synthesizers. You sometimes have problems with latency, as you do with every digital synthesizer interface thing. But yeah, once you pass the latency issues, I didn't jump into any other issues. Yeah. Um, yeah. If yeah, for that I can send. Yeah. So if Candera was not physically with me and I was playing with my synthesizers, they would not be able to listen to them. Yes, for sure. Unless you can do audio streaming, but we haven't really. This program Flock also does that, but we haven't really tested it, to be honest. So I can tell you how good or bad it is right now. Yeah.
So when you run it, it's just this. And actually, let me go to the actual website. This is a really cool open source project. You can use any of these open source languages on it. So for example, sclang is native supercollider. You can run any of them. You just type here whatever you want. In our case, we were using Tidal and Hydra. And then you create a session, and then you join, and you can, if you want, you can do audio streaming, and it sends the audio to all the clients. But it's, you know, there's latency and stuff. So usually we just use it because it's the fastest way to collaborate. But also most of the times we play alone, so we don't.
I can show,
Yeah, you can use. You can show. You use what? Atom?
We use Atom, which has now been abandoned, but we're still using it. For now, we still don't have a better option because we use Hydra with the code, and right now I don't know any other text editor that enables this and Tidal at the same time. So we're still using Atom until we have a better option. Yeah.
Fuck Microsoft. Are we allowed to curse? I'm sorry. Yeah,
this is
go
how
ahead.
we usually perform, and here then I can run super.
I was asked that the questions go on here, so the live streaming can also.
So you had a specific language for the visuals. Can you do combine any visual language like GLSL shaders or the things that we're used to in the demo scene, like Shadertoy or Ponzomatic?
If I would say if you are able to live code shaders, damn, I would love to be at that level. I'm very basic. I do like this super simple function, you know. No, but yes, you can run it. You can run. It's basically run on JavaScript, and you can link it to, for example, processing. It has P5, so you can run GLSL inside processing. Yeah.
I'm not sure if you can run it directly. Only if you have like a library for JavaScript that enables running GLSL and then on the browser. That. No, okay, so then you can through P5. Yeah, definitely. Yeah, because P5 is already embedded into Hydra.
Yeah, but not all the functions.
No,
You need to do yeah.
libraries. So
Yeah,
instead
yeah.
of writing the functions directly. You
But I
need
mean, it's open source, so.
yeah, you need to call it with lambdas and stuff. There's a lot of documentation.
I would actually love to do that if someone is up for it. Like that would be super. We know the author of the language of Hydra. I think she would be super happy if we managed to make it easy to run shaders on it. Yeah.
No, apparently you can through P5.
Yeah,
So
but
you can
not
do,
natively.
I think you can do shaders in P5 exactly.
Yeah, but it doesn't work currently like natively with Hydra. Yeah. Any other questions?
Yeah, basically I was just wondering how we would do like modulation of patch parameters in live context. So I've seen you had like the Platts preset with the harmonic and morph parameters, and was wondering if you would this also work like this cycle notation, pattern notation, if this also works for additional parameters, or how you would go about modulating those in a rhythmic way?
So you can create.
Can you show the synth def?
Yeah, exactly.
So basically, how this works is you can create any synthesizer on SuperCollider, and that means you can put any VST, basically any audio software, piece of software you want into here, then you define it, and then it basically exports a property that is accessible from Tidal. And once for example, plates is a synth, it's this one.
Yeah,
You're in front, but...
the the major part of the code from Plates is an open source project because the mutable instruments are open source. So the UGen is not made by us. It was just it's an open source project. You can grab it, and then you can just create a synthet. And you can give it the parameters whatever name you want. And when you are playing with Tidal, when you choose the sound that is the same as the synthet, as the name that you gave to your synthet, it will look for the parameters that you assigned in the synthet. And then, for example, if I pass a parameter called morph, it will replace my variable there with the value that I pass it through Tidal. And the cool part is that you can pattern all of this. So every parameter can be patterned through time. Yeah.
Just as follow-up, was wondering once this in place, if you want to modulate it over time, like the specific parameter, not set it, how the notation in Tidal would look like for that, and how you could play with that one.
So it's basically the same as any other parameter. So can you pick it up? So it's basically the same. Yeah.
Yeah. So as in any other parameter. So for example, if you have.
So here I have the plates code. And so here I have, for example, harm, but the parameters that I defined in the synthet. But this is actually a shortcut that I created because you actually need to call it, because this is Haskell. Tidal is basically just on top of Haskell. So you actually need to call it like this, which means that you're passing a float. PF means that it's a float. But you can create shortcuts by doing like this. Let PF harm, let harm equals PF harm. So after I run this, I can just call it by using harm. And then, for example, if I want to modulate it slowly with the sine wave, I would just do like slow 8 at sine. Sine is a sine wave. 8 means that the amount of the cycle is 8 cycles. And yeah, once I run this, the harm parameter is going to be modulated slowly by sine wave. I can also do random. For example, if I do it like this, 0, 0.25, 0.5, this means that every cycle it will choose randomly between these values for that parameter. So there's a lot of ways, as any other type of modulation, there's a lot of ways to get into it. But what? Go ahead.
I don't know what to do that symbol.
What? Ah, just like, okay. So is it this?
Yeah, so you can do exactly. So if you want to do that, then it goes 0, then 1, then 0,
like
then 1.
What it means is like first cycle it will go 0, next one it will go 1, and if you have
Yeah.
another one, the other one will go. The next one will go.
Yeah, this
It
is
comes back to the beginning. It's like this is just a way to represent. So this is the most interesting part that I find about Tidal is how easy it is to define these movements in just like 5 or 6 chars, you know. So here we define this is that every cycle, it changes, and if you have more, it just moves upward and then back to the beginning. Yeah.
you can also pattern the type of algorithm used. So you can pattern that in one cycle it goes forward, and another cycle goes random, and another cycle goes. Yeah, everything is patternable. That's the cool part. Yeah.
Yeah, you can pattern everything. Even the beats per minute, you can actually pattern that as well.
Yeah. I like doing that. People get very annoyed. It goes. Yeah.
Any other questions? Any more questions?
Thank you so much for the presentation. and
You're
for
welcome.
the
Thank you.
performance.
Can we do a shout like a plug for our collective?
Yeah, of course, go for it.
Yeah, just follow us on. Oh wow, we're in a camera. Just
we're
follow us on Instagram.
Yeah, we're called Not Binary Code. We used to be Toplap Lisbon, which we rebranded this week to Not Binary Code. And yeah, our Instagram is nbcode_. And if you're interested or know anyone that's interested in doing music with live coding or participating in algorithms, if you've been doing it for a bit, then just let us know. We really want to meet more people that do that. We don't know that many people here, and we really want to know more people.
We have dates and we have slots, so you can come jam with us and play with us to practice and stuff, and we can have some fun together. Yeah. Thank you.
Okay, thank you. Okay, so